Hello friends, myself Saurabh Sharma. I am coming with question number 12 of Pathfinder kinematics. So firstly I want to read this question. A cylindrical pipe of radius r is rolling towards a frog sitting on the horizontal ground. Center of the pipe is moving with a constant velocity v to save itself. The frog jumps off and passes over the pipe, touching it only at the top, denoting air time of the frog by t, horizontal range of the jump by r, and acceleration due to gravity is g. Which of the following conclusion can you make? First one is t equal to 4 under root r by g. T is greater than equal to 4 under root r by g, and r equal to 4 under root over g r minus v into square root of r by g, and r is greater than equal to 4 times square root of gr minus v into square root of r by g. So now just see the situation. What the situation is given? Situation is given, this is a horizontal surface and one cylinder is moving with the velocity v here, and the radius of cylinder is say called small r, and towards the frog means somewhere the frog is placed here, and this frog is moving with a speed of u. Okay, then if this is your x-axis and this say called y-axis, then there is a one component of x-axis, it is ux, and other component of the velocity is uy. So what is happening? Just look at, if this is start to jumping, at the same time this cylinder is also moving. So at somewhere the cylinder is coming here. Let's assume the cylinder is coming here, and if this cylinder is coming here, so for identical cylinder, so it is coming somewhere here. Is it clear? And the velocity of this is here. For the safe jumping, the frog is going like this. So this is the safe jumping. So here the velocity is ux only pending. This is the topmost trajectory of the particle. Let us assume, and uy is 0. Our velocity along y direction is 0. Okay. So finally you can say that, sir, this frog is performing a projectile motion. So if the frog is performing a projectile motion, then look at the maximum height of the frog is 2r. So we can use the maximum height formula is maximum height of frog is 2r. So this is a safe condition or safe jumping. So if it is 2r, then we can say that the maximum height is equal to, it is uy square upon 2g, because acceleration is given, it is g. So h max is equal to u square by 2g. So we can say that h max is 2r is equal to uy square by 2g, and finally the uy is 2 square root of gr. So if uy you calculate it, then you can say that the time of flight of the frog is, so time of flight of frog is t is equal to 2 uy by g. So finally the t is equal to 4 square root of gr by g. So you can say that the time of flight of the frog is square root of, it is r by g. This is your first answer of this question. So we can say that there is no condition the time taken is greater than equal to under root 4r by g, because we are going with the safe jumping. So safe jumping means this frog does not collide with the cylinder. So if it is touches, if it is passes, here it is given in this question, it is given jumps off and passes over the pipe touching it only at the top. So if it is touching it only at the top, means maximum height is uy square upon 2g, which is equal to 2r. Now I want to go with the range. How much horizontal range covered by the frog? So let's see, at this distance, at this time, some distance is covered by this cylinder, and at this time some distance is covered by somewhere it is collide. So this is the distance covered by frog, let us say df, and this is the distance covered by cylinder is dc. So this distance is the range. Best part of this, how much horizontal range. So now distance I want to calculate one by one. So if you want to go with the distance covered by cylinder in time capital T, which is equal to 4 square root of r by g. So we can say that dc is equal to v into t. Okay, and the same horizontal distance covered by frog in same time or in time capital T. So df is equal to, it is ux into capital of time. So you can say that how much range is covering. So range is nothing, it is equal to df minus dc. So range covered by frog r is equal to df minus dc. So r is equal to ux minus v into t. Finally, with the help of this, we can say that the ux is equal to, it is r by t plus v. So finally, you can calculate the velocity along the x direction in terms of range, time of flight and velocity. Now just look at this point, and this diagram is showing that if it is jumping here, so here this is the radius of cylinder. If the radius of the cylinder is less than equal to the radius of curvature of the frog, what? For safe jumping, the radius of curvature by frog is greater than equal to radius of cylinder. That is called, you can say that it is radius of curvature, it is radius is greater than equal to small r. Okay, now how to calculate the radius? So we can very easily calculate the radius of this path. So if you want to calculate, then here it is normal acceleration is acting. So an is equal to ux square by radius, which is radius I want to write here. So finally radius is equal to, it is ux square by an, and an is nothing, it is equal to g. So it is ux square by g. So finally we can calculate the radius. So radius is ux square by g is greater than equal to r. So you can say that the ux is greater than equal to square root of gr. And what is the value of ux? It is r by t plus v is greater than equal to square root of gr. So you can say that the range is greater than equal to square root of gr minus v into time of flight. And time of flight is nothing but it is equal to 4 square root of r by g. So r is greater than equal to square root of gr minus v into 4 root r by g. So this is one of the answer. So thank you so much for watching this video. A and D is your answer.